that, just this last bit here maybe. Okay, so the recording stopped. I'm not sure where it stopped, but we have the centered interval. Do you think it stopped there?
I think it was a little bit after.
A little bit after. Okay, so we have the centered interval where we choose 0.01 on either side, and we do the y2 minus y1 there, so we got the 6. Then I was showing you that graphically, just repeating myself a bit here, just graphically, if you drew it and you tried to eyeball it, and you did this, you can actually do it accurately using the slope, which is 6/1, rise over run, to get the second point. So instead of eyeballing it, you can actually get the proper slope using the method we have, right? And so that was this idea. Then I talked about the fact that here, what they wanted was, okay, instead of punching in a bunch of decimals, right? Because that whole question of how many decimal places to do, you don't really want to do a bunch of decimal places, so we start to develop a formula. H is the difference between the P and the Q. We're going to do that. So if you're saying, okay, this seems backwards and seems like brute force, we will stop doing this eventually. We're going to do into a formula. So I'll show you that. I'll start that in a section. And then this sentence here is that the best estimate occurs when the interval is as small as possible, which means limit, right? So the limit as close as P and Q are going to be as close as possible. And that's the beginning of calculus. Okay, so I'll stop the recording.